Hello, I am Manoj from Team 16 O Division. My teammates are Ribav, Sanjay and John. And our guide is Vinay Talgeri sir. Our need statement was lead through programming, and the problem definition we came up with is somewhat like this. To design a machine semi-automatic and portable which can draw simple or engrave simple types of geometric design, and the machine should be 2 feet into 1.5 feet into 1.5 feet height, and the workpiece or a cardboard wood should be less than A3 size. The build cost should not exceed 6,000 rupees, and it should have an emergency stop button. Function tree. The function tree, recording the movement, repeating the movement comes under robot training, drilling and writing mechanism, indication and casing. The subsystems we identified were somewhat like this: robot training and writing mechanism, drilling and writing component holders to hold all the components like pen and paper or cardboard, indication and casing. We came up with three concepts mainly: XYZ plotter, robotic arm mechanism, and a 5-bar. The selected concept was XYZ plotter because it was more precise than the others, and it suits our problem definition more than others. Virtual implementation. Virtual implementation 3D modeling. 3D modeling. This is a 3D model: X-axis, Y-axis, and the Z-axis. Z-axis has a lead screw, and X and Y have a belt drive system. This is a pen holder. This can be easily switched with a DC motor holder. We just need to replace these. There will be a slot, and these are the encoders, rotary encoders. This will be connected to the stepper motors, making it as a closed loop. The total integration would look somewhat like this, leaving one side open. This is a circuit diagram. Here we have three encoders and three motors controlled by A9488 stepper motor drivers. This is a flowchart. We need to draw or write or a 3D model and transfer it to Inkscape software. Any other software which can convert images to the G code is okay. Then after getting the G code, we need to send the G code to the Arduino. To send that, we can use G code senders like UGS or Xloader or Processing 3. Once it is fed to the Arduino, stepper motors come in action, and encoder get the values from stepper motors and feed it back to the Arduino, mm, which helps it to repeat the same process many times. This is bill of material, and the main components are Arduino, NEMA 17 stepper motor, lead screws, CNC shield, and stepper motor drivers with belt drive, motor sizing and battery sizing. The required torque for us was around 2.8 kgs. So to be on a safer side, we choose a stepper motor with 3 to 4 kg centimeter torque, that is NEMA 17 stepper motor. Each stepper motor draws 1 amp current at 12 volts. So, and we are using 3 stepper motors, and other components also need current. So it was estimated that the system will work perfectly at 12 volt 3.5 amp power supply. To run the machine on battery for 3 hours, we need 12 volt and 10 amp hour battery to run it successfully. Functional specification. The main functions were to record the movement, repeat the recorded movement, and to hold emergency stop and indication after every cycle. Modeling and simulation. Before going to simulation, I have already built it physically. So let's say this is a interface of the UGS, Universal G Code Center. This is a visualizer where we can track the probe or the drill. This is a jog controller. We can also move the stepper motor or the probe with help of this. And this from here we can upload the G codes we have created from a software. This is a CNC shield. It is fed to CNC shield. The shield are nothing but hardware component which are stacked on the Arduino. Shields use a firmware to control the stepper motors. The stepper motors are now being controlled with a jog controller because there is no G code here. We can also change the feed rate and step size of the each stepper motor individually, which is very convenient. So this is the simulation after uploading to the CNC shield. So after uploading the stepper motor move, and here I have used instead of encoders, here they are potentiometers and servo motor because those are not available in the Thinkercad. So both are actually the same, but the difference is it has a limit of 360 degree. So the first button uses to record the moment, and the second button is to pause or play the circuit. So it is recording right now. The LEDs are just for the reference. And once it is recorded, it will be repeating a number of times. So this was it. Thank you.